So this is what we are seeing. So here, what is a biomaterial? We know that any material, it's a combination of so many metals put together, or ceramics, or so many chemicals put together, and it is bounded together to form a material. And what is a biomaterial? So any material which is used in biomedical applications and biological concepts, so that can be considered as a biomaterial. And here, what is the use of such material? So this material can be used in our human body to replace some functions. Okay, so we can say that this biomaterials, it acts as a supportive material for our body. Hope you might have seen so many applications where this biomaterials are being used. And one more important thing is this biomaterial, though it is made up of so many other chemicals, all these things, so it can have a biocompatibility. It can work with the fluids which is there in our body. So totally those metals and our fluids are totally foreign materials to each and everything. But still they can work together, and they can make, and they can coordinate with each other, and they can result in a particular specific function. So such biomaterials, they are known as biomaterials. And this biomaterials, they can be prepared either in the lab, or it can be prepared in a special labs. Okay, so it can be a combination of polymers, metals, ceramics, and it can be considered as a many combinations. So there are many types of biomaterials that we are going to see now. So we can say that this biomaterials, it can be classified as metals, or it can be of polymers, ceramics, and semiconductor materials. So in this case, metals in the sense, hope you might have seen, metals in the sense, you might have heard about the plates, steel plates. So if there is any fracture in the hand or in your body, generally they go for replacement of, that is, they used to keep the plates. Why the plates? Because it has to keep the bones intact. For that, they used to place the plates and fix the screws. Okay, so likewise, so these metals are used in various applications like dental implants, orthopedic screws, and fixations. Likewise, semiconductor materials, so they are also used for biosensors. Hope you might have studied about biosensors. They are used, semiconductors are used there. And polymers are used for ocular implants. So we are making use of that lens, contact lens. So that is also considered as a biomaterial, which is a foreign body which is placed in our human body, human eye, where it is in contact with the fluid. So you have to understand how a foreign body can be made compatible. Okay, so it is made in such a way, it is manufactured in such a way that it has contact with the body fluids. Okay, and our body also accept that foreign body. So that's the speciality of that one. And then you have the ceramics in the sense for dental implants. So if there is any hole in the tooth, no, generally they go for, initially they'll go for simple cement filler. Then they go for so many metals. Okay, so ceramics are also used for heart valves also. So we have wide applications of this biomaterials. So when we consider our human body, look at this picture. Hope you can see this picture, right? So in this one, we have from head in the sense from the top of our path, okay, till the last end, biomaterials can be employed. So you can just have a look at it. So starting with the cranial part, okay, brain also, in that the covering of the brain. So that also that is replaced by biomaterials. And you have the lens, contact lens, that is also a biomaterial. Ear implantation, hope you might have seen that one. So that is also biomaterial. And you have the maxillofacial reconstruction, okay, and facial, if the face also can be replaced, okay. And dental part, various clips you are using, okay, root canal can be done. So all these are nothing but what? Biomaterials. So starting from the head till the lower level, okay, when you have the ankle, so till that one, you can replace the joints, you can replace the hip joints, you can replace the spinal cord, and you can replace the heart, okay, heart valves also. So all these, in all the areas, biomaterials plays a major role, important role. So what are the various commonly used biomaterials? One is, you have the silicone rubber. Okay, so we know that this is also a biomaterial which can be used for making catheters and tubings. So you know that catheters, so that has to be catheters or tubings that has to be inserted into your body, right? So that tubing also have to be made from a proper material. So it should be acceptable by the body, right? For that you are making use of that silicone rubber. And you have the vascular grafts. So Dacron is being used, cellulose for dialysis membrane, and intraocular lens, okay, a contact lens. And then you have the bone cement, okay, and then you have the catheters, pacemaker leads, okay, and various orthopedic devices, dental devices, and wound dressings. You know that for dressing also we make use of wound dressings, we make use of certain materials, right? That sutures, when you want to put sutures also, that material. So all these materials have to be properly processed and have to be properly used. So now these are the various applications that can be used for breast implants also. One more important thing is for breast implants, for stents, okay, and for dental implants, and you have the artificial ligaments and tendons. So all these areas you can use these biomaterials. So coming to the history of the biomaterials, that is in those days you might have heard about that. Have you heard like that? They have got, a person might have used a gold tooth. தங்க பல் வச்சிருக்காங்கன்னு சொல்லிருப்பாங்க. Have you heard about that one? Gold. So in those days only gold was used in dentistry, okay, and then as time went on it was replaced by some synthetic implants, and that material, the specially used material was PMMA, that is polymethyl methacrylate, okay, and then Dacron fabrics was introduced, and then stainless steel. We know that for steel implants, okay, initially in our body, if there is any fracture, that will be replaced by stainless steel. So that is used for total hip replacement. So likewise, starting with gold, okay, in the dentistry part, it went on, it kept on increasing. And you also can see that in the year 1960 and 1970s, there was a specialized field, and that is known as biomaterials field. And in 1975, you had the Society for Biomaterials. Now we have Society for BMIE, okay, Biomedical Engineering Society. Likewise, there was a separate society which was initiated in the year 1975. And there was old applications include where the loose teeth, no, they were bound together. Okay, thanga palla vechu thanga kair vechu katti irukanga. You might have heard about this statement. Okay, so gold wires was used for tying the artificial tooth, okay, artificial teeth, and the bone plates also were introduced. And the next level was blood vessel replacement. Okay, blood vessel replacement also was done using artificial valves and hip joints. So this is the one. So you can just see for nose construction, steel screws for fixation, okay, for a total hip replacement, for blood vessels and heart valves, artificial hearts. All these are the major applications. So one important applications was skeletal system. So in this skeletal system, it was used for joint replacements, okay, and joint replacements. The materials that were used was titanium, stainless steel, and polyethylene. So the next one was plates. You might have heard about plates. Okay, plates for fracture fixation. For that also stainless steel, cobalt, chromium alloy was used. And for bone cement, for PMMA. And for artificial tendon and ligament, Teflon and Dacron. And for dental implants also, this biomaterial was used. The next one was cardiovascular system. So cardiovascular system, here you have the blood vessel, okay, blood vessel processes. In that, the materials like Teflon and Dacron was used. And for heart valve also, it depends on the tissue, okay. So artificial tissues were also used for making the heart valves. And for making the catheter, as we have already seen, we have that silicone rubber and Teflon. All these materials are used for this one, okay. And for organs, specialized organs, artificial heart, okay, the total function was replaced by artificial heart. For that, polyurethane was used. And for artificial kidney, cellulose and polyacrylonitrile, okay. And then For a heart-lung machine, silicon rubber was used. Okay, so all these are the various materials that are used for specific organs also. And for senses you might have seen cochlear, ear implantation. So they would have used some electrodes for that is where the air conduction was not proper. They go for bone conduction. Okay, so directly the signal can be processed in the inner ear, and for that you make use of platinum electrodes. And then you have the intraocular lens, contact lens, and then you have the corneal bandage. So all these are various biomaterials used for sensing purpose. Now coming to the characteristics of biomaterials. So we have seen what are the various applications of biomaterials, what are the various classifications of biomaterials that are used for various applications. Now, when you are using a foreign material in body, the requirements that should be met out by such material, then only such material can be employed in biomedical applications, right? So otherwise it will react with the body and it will create problems. So the first requirement can be first level can be classified as physical requirement and chemical requirement. So what is meant by physical? Physical in the sense, for some applications, for bone, for steel and all, what is the physical requirement? It should be hard. And for some application like heart valve movement, it should be flexible. So these are the physical requirements. So it should be hard as well as it should be flexible based on the applications. So the next one is chemical requirements. Chemical requirements in the sense, so when this material is placed in our body, there should not be any chemical reaction between that body and the tissue. And it should not create any toxicity in the body. It should be non-toxic to the body. And when you are replacing such material, it should have a long-term replacement. It should not again and again within 1 month this material should be replaced. So you cannot go on with that one. It needs money, it needs time, it needs effort, it needs special people. So these are all some constraints that are being used with when you are using this biomaterials. So long-term replacement is also one more important requirement. Now coming to the mechanical and performance requirements, so we can see that this biomaterials, okay, so they should be designed using some software. First they have to do the simulation and then they have to do the hardware. So for that they make use of CAD, that is computer aided design. So it should be properly designed. What is its dimension, what is its radius, what is the thickness, so all these things have to be properly designed and then it has to be manufactured. Okay, so it's very, very essential for manufacturing as well as for testing. For example, you can just see that when you have the intraocular lens, so it deals with the anterior part of the eye. Okay, and then hip joint, it deals with the articulation joint space. And the heart valve, when you want to replace the heart valve, that has to be present in the cardiac muscle and it comes in contact with the blood also, right? Blood as well as the soft tissue. And a catheter when it is inserted in the body, so you know that it has to keep in come in contact with the artery, the vein or the urinary tract. So very, very okay, it should be, we have careful precautions have to be taken when you are using this biomaterials. So and not only that, the size, the shape, the geometry, the mechanical properties and what is the response from the body, all these things have to be studied for each and every material that is used as a biomaterial. And then you have the physical thing or the electrochemical properties of the material. So you know that when you are using a biomaterial for hip prosthesis, it should be strong and rigid. It should be strong, no? If it doesn't have strength and if it is not rigid, surely it is of no use. And the tendon material, it should be strong and flexible. Okay, flexibility is also required. And the heart valve have to open and close, so it should be flexible and tough. And the dialysis membrane, you know about the dialysis membrane, it should be strong and flexible, but not elastomeric. Okay, it should not lose its shape when the liquid or something stops passing through it. And the articular cartilage, it should be soft and elastomeric. Okay. And apart from all these physical, chemical, all these properties, you have certain properties, they are known as biophysical properties. So biophysical properties, in the sense, it deals with the lubrication, the permeability, all these things. Okay. For example, the dialysis membrane, it should have a specific permeability. Okay, then only it will allow what? The waste materials to be taken out from the body to be collected, the dialysate. Okay, so permeability is required. The next one is the articulation cup of the hip joint. So, for example, you just assume that you have your hip, and if there is any fracture, it is being replaced by a biomaterial. So, in that hip, no, so there should be proper lubricity. So lubricant, then only those joints, they will not glide with each other, and there will not be any pain. Otherwise, it will create pain. And intraocular lens also, they have the clarity as well as the refraction requirements. Okay, the permanent lens will be placed now, so that is also there are certain requirements for all these things. So when you want to go for such material combination, it's not possible only with a biomedical engineer to work. So you need to come in contact with the physics people, the chemistry people, the mechanical people, the chemical people, and the material science people, in order to go on with the design or the application of this biomaterials. Is it okay? So it's not a one-man show. It's only it is possible only with a group work, okay, or a team work with people from various disciplines. Otherwise, it will not be helpful. And the another important requirement is duration of contacts. So we know that a catheter, it may be required only for just 3 days, and for bone plate it requires 6 months or longer. And the leaflet in the heart valve, when you want to replace the heart valve, no, in that case it should be flexible, and it should open and close 60. Okay, so many times. So, and not only that, it should work till the lifetime of the person. Otherwise, it's not possible to again and again replace the heart valve. So for all these things, you have to consider the mechanical performance requirement. Okay, mechanical and all the biochemical or the physical. So all these requirements are necessary so that this biomaterials can be employed in the body and it can last long. And one more important thing is, when you want to go on with the design of the biomaterials, there are certain rules and regulations that you have to follow. So there are certain rules that is being posed by ISO, that is the International Standards Organization, and we have to, the manufacturing industry or the manufacturing people, you have to comply with the standards. And then only what will happen, the cost for that will be reduced. So when you go on with the biomaterials, working on the biomaterials, it's little bit costly. You can say that it is costly, but more efforts are also required to get the regulations clear. So now we'll have a break, 1 minute. Ma'am, can you go on with the first video?
Ma'am, we'll play the video now.
Ma'am? First video, polymer materials.
Ma'am, we'll share the screen now.
Smiley ma'am?
Ma'am, 1 minute, ma'am.
Okay. Okay, hope you would have seen that one. So it's just the basic materials. Okay, the basic materials and what are the applications of that materials. Okay, so the next one is we'll just go on with the applications. Okay, so in that case, the main, okay, this biomaterials, what are the problems that are being faced by biomaterials? One is it creates infection, and the next one is it also suffers due to fractures. Okay, and there might be some pain or loss of function. So that is also the drawback of biomaterials when it is employed in our body. Okay, and the next three things. Okay, in this presentation we are going to see three main applications. One is in the area of dental, the second one is in the area of orthopedics. Okay, and then the third one is related to the area of cardiovascular part. Okay, so these are all the areas that we are going to see for the next 1 hour. Okay, for first one is for dental. Dental, I hope many of you would have gone through this procedure. So if there is any hole in the tooth, no, you have to go for filling. For that filling, generally in those days they went only for cement filling. But that cement filling, it will once again it may create problem, right? So in that case, they went for that metal filling. Okay, and the alloys are also used for removal of the tooth, and you know that you have to maintain that root canal, right? For doing that root canal also you have various materials. So for that is one application. The second application is major people when they undergo any that is accidents, or if there is any injury to the body, they have to go for replacing the that is joints or implants. Okay, and that is one of the second important area where it is employed in skeletal implants. And the third use of biomaterials is cardiovascular in the sense for all these things. It includes all with related to blood. Okay, that is for dialysis, oxygenated membrane, and for blood vessels and heart valves, catheters. So in all these areas come under cardiovascular implants. Okay, so now first we'll move on with the dental implants. We know that we have tooth, though we maintain it by brushing it in the morning as well as in the night. At times now what happens, it is being decayed. Okay, there are certain cavities that are being formed in the dental area. Okay, this part, and demineralization also occurs. Okay, so in such cases there will be tooth loss, and that have to be replaced. These teeth no, they have to be replaced or restored by using variety of materials. So what is a dental implant? Dental implant in the sense which are used to some as age goes on, tooth may fall. At that case also they have to go for some our grandparents, they would have kept such artificial teeth, right? So that is also biomaterial. So they come under both prosthetic dentistry as well as cosmetic. So nowadays we want to improve our facial look as well as the smile to be a better one. So for that, what we do, we go for cosmetic dentistry. If certain people undergo any accidents, if they lose any bones, or if they lose any teeth, no, it has to be replaced, because face is the one area where we have to see people through, right? So that has to be adjusted. For that, we make use of dental implant. So now I can say that one of my scholar, actually recently she met with an accident, and totally she has her face is totally disfigured, and now her teeth part also is totally destroyed. So in that case she has to do all these implants. So then she was sharing her experience, and she also had so many fractures on the face. Okay, face. So all the bones were totally one day her life was given, okay, by God's grace, but everything, she lost all the bones in her face. Totally her face was disfigured. In that case, now she has gone for that cosmetic. All the dentistry has been used here, as well as all the bones are being replaced in the face. And now, so what are all the areas? When do we need this dental implants? One is because of tooth decay. The second one is due to gum disease. We know that gums, bleeding gums will be there for few people, and it will be of red color, and you can periodont is okay. So that is one of the inflammation that is being created, and the next one is root canal failure. So in that case also, they go for dental implants and tooth loss. So these are all the reasons where we go for dental implants. So now we'll have a video how that biomaterials are used. Ma'am, and the second one, dental restoration video.
Okay, ma'am.
When your teeth need restoration, we can choose from several different materials, including silver amalgam, composite resin, gold, porcelain, and porcelain fused to metal. Amalgam is the most common material for fillings. It's an alloy of mercury, silver, copper, tin, and sometimes zinc. It's strong, durable, and quick. However, more tooth structure must be removed to hold an amalgam filling in place, and the metal is not natural looking. Composite resin is a mixture of plastic resin and microscopic particles that is also commonly used for fillings. Composite resin is about as strong as amalgam, and it may be as durable in some circumstances. It's bonded to the tooth, so it requires us to remove only a minimum amount of tooth structure. It's gentle on the opposing teeth when you chew, and we can match it to the color of your teeth. Composite resins can also be used to create onlays and crowns.